Welcome to this explainer. Today, we're diving deep into the complex virology and clinical reality of subacute sclerosing panencephalitis, or SSPE. It's a devastating condition, but one that perfectly captures the intersection of viral persistence, neuroimmunology, and public health. As evidence-based practitioners, we really need to understand this.
All right, here's our agenda for today's explainer. The resurgence of SSPE, the core mechanisms of viral persistence, clinical and atypical manifestations, diagnostics, and finally, clinical implications and management. Let's get right into it.
Part 1. The resurgence of SSPE.
So the absolutely crucial thing to understand right off the bat is that SSPE isn't some novel pathogen. It's a delayed, devastating complication of a primary wild-type measles infection. Basically, it's a chronic, progressive inflammation of the brain's gray and white matter, and it's driven entirely by a hypermutated form of a virus the patient acquired years, sometimes many years prior. If we look at the pathogenesis timeline, you can see how this builds. Typically, a patient, usually a child under 2, is infected with wild-type measles. Their immune system seemingly clears that acute infection, but then there's a latency period. We're talking an average of 7 to 10 years where the virus just hides. Then this insidious clinical phase begins, marching inevitably toward cognitive decline, severe myoclonus, and eventually a vegetative state.
Now, this stark timeline brings us to a fundamental scientific mystery. Seriously, how exactly does a monotypic virus manage to evade our robust cellular immune responses, sneak across the blood-brain barrier, and then establish a silent, decade-long persistence in the central nervous system? It's a massive question.
That brings us to Part 2, core mechanisms of viral persistence. To answer that mystery, we have to look at the genetics. What's truly fascinating here is how mutations in the viral M protein and F protein allow the spread. Because of defects in the M protein, the virus actually fails to assemble in blood normally, which helps it completely fly under the radar of immune detection. At the same time, there's this leucine to tryptophan substitution at position 454 in the F protein. That makes the virus hyperfusogenic. Basically, it allows the virus to spread directly from neuron to neuron, stealthily, without ever entering the extracellular space. Over time, this chronic, smoldering infection triggers the hyperphosphorylation of tau proteins, leading to secondary neurofibrillary tangles and catastrophic neuronal death. It's like a slow-moving fire in the brain.
But as scientists and evidence-based practitioners, we have to acknowledge the gaps in our knowledge. We still don't fully understand how the virus initially breaches and infects these neurons. You see, the measles virus normally uses SLAM and Nectin-4 receptors to enter cells, right? But neither of those are expressed on human neurons. So how does it get in? Well, whether infected immune cells are acting as a sort of Trojan horse across the blood-brain barrier is a huge focus of current neurovirology research.
Moving on to Part 3, clinical and atypical manifestations.
Clinically, the classical progression of SSPE unfolds across 4 defined, quite tragic stages. Stage 1 is notoriously tricky. It often gets misdiagnosed as psychiatric illness or just failure in school because it starts with behavioral changes and cognitive decline. It really isn't until Stage 2, which brings massive, repetitive myoclonic jerks and seizures, that the neurological severity becomes undeniable. From there, extrapyramidal symptoms and rigidity dominate Stage 3, which inevitably pushes the patient into the akinetic mutism and vegetative state of Stage 4.
Now, while this is classically a pediatric condition with a standard progression, we are increasingly seeing atypical cases in the literature. We're talking about adult-onset presentations that seriously complicate the differential diagnosis. In some of these cases, the latency period can stretch out to 27 years. Or, on the flip side, it can manifest as a fulminant course, causing a severe vegetative decline in as little as 3 months. It really throws a wrench in the typical diagnostic framework. Take a look at this. Recent case studies have documented highly unusual phenotypes like gelastic myoclonus. This is where dyskinetic movements are accompanied by these mirthless, almost laughter-like vocalizations. It's a presentation that suggests complex involvement of the basal ganglia and subcortical networks. It's a stark reminder that SSPE can present with incredibly varied movement disorders that can easily mimic other neurodegenerative or autoimmune conditions. Which naturally leads us to Part 4, diagnostics and key evidence. So, given those tricky presentations, how do we confirm it? The cornerstone of an SSPE diagnosis rests on Duyken's criteria.
The major requirements specifically focus on identifying highly elevated anti-measles antibodies. We're looking for titers of 1 to 4 or higher in the cerebrospinal fluid or 1 to 256 or higher in the serum. Finding this profound immunological response and mapping it against that clinical history of progressive cognitive or motor decline is your primary anchor for a definitive diagnosis.
Then you combine those major immunological markers with the minor criteria. In cases where the clinical picture is still a bit ambiguous, you might look for elevated globulins in the CSF, specifically greater than 20% of total protein. Or you might look for specific EEG findings. Ultimately, a brain biopsy showing typical necrotizing panencephalitis with viral inclusions might be necessary to definitively rule out mimics like autoimmune encephalitis. But let's talk about those EEG findings because this is fascinating. Look at these high-voltage synchronous slow waves. These are known as radar-maker complexes, and they're essentially pathonomic for SSPE. If you're seeing these periodic, stereotyped discharges popping up every 2 to 3 seconds on an EEG, especially in a patient with cognitive decline and myoclonus, SSPE absolutely must be at the very top of your differential diagnosis.
Finally, Part 5, Clinical Implications and Management.
The therapeutic reality here is frankly stark. As you can see, the natural disease course is invariably fatal, typically within 1 to 3 years of clinical onset. We have no known cure. Now, aggressive palliative interventions, like combining oral isoprenazine with intrathecal interferon alpha or ribavirin, can occasionally stabilize a patient's progression. It can provide a vital time window and slightly prolong survival, but unfortunately, it cannot reverse the extensive neuronal apoptosis that has already taken place. So what's the big takeaway? Ultimately, SSPE is a 100% preventable tragedy. It is a direct consequence of a wild-type measles infection. Therefore, incidence is inversely related to MMR vaccine coverage. Unvaccinated children who catch measles before age 2 are at the absolute highest risk. Maintaining high herd immunity through vaccination is literally our only defense. And to be clear, the vaccine uses a lab-adapted strain that lacks those hyperfusogenic capabilities, so the MMR vaccine itself cannot cause SSPE. It only prevents it. I want to leave you with a final, provocative thought as we wrap up this explainer. With global vaccination rates faltering and wild-type measles resurging in various pockets around the world, is our healthcare system prepared for the inevitable wave of SSPE cases a decade from now? Remember, if a primary measles outbreak happens today, the silent neurological time bomb of SSPE won't detonate in our clinics for another 7 to 10 years. Keep this pathology in mind, and as always, let the evidence guide your practice.